What's up, math fans? Here's an SAT question I've seen. If today is Monday, what day will it be in 80 days from now? And there's a bunch of different ways to figure that out. You could actually draw a calendar out and count the days, but there's a pattern. If you establish a pattern, you can do it mathematically, all right? And basically, I want to establish patterns in this video where I talk about simplifying powers of imaginary numbers. And imaginary numbers are numbers that don't exist. And here's what I mean. You first learn numbers and you learn the counting numbers and the whole numbers and the integers and the rational numbers and the irrational numbers. And all of those numbers have their own properties and definitions, but they all exist. They all come together and form what's called the real number system. Real number system means that if I had an equation and I got a solution, the solution could be any one of those real numbers. But what if you have trouble finding that solution? And here's what I mean. Let's say somebody asked you for the square root of 25. The answer is easy. It's 5. Why is it 5? Because 5 squared gives you back 25. But what if they asked you for the square root of negative 25? Think about it. What number squared gives you negative 25? If you think it's 5, 5 squared gives you positive 25. If you think it's negative 5 squared, a negative times a negative, still gives you positive 25. No real number exists that when I square it, I get negative 25. Therefore, this does not have a real solution. It has an imaginary solution. It doesn't exist. Here's where they came up with this imaginary solution. They said, well, if I can't figure out the square root of something, I can factor it, break it down until I have simpler factors. So I'm going to break this down into radical 25 and radical negative 1. 25 times negative 1 is negative 25. And I know the square root of 25. That's easy. Just said it. It was 5. I still don't know the square root of negative 1. So here's the first fact of the video. Square root of negative 1 is don't know. It's imaginary. It's I. Some number exists that when I square it, I get negative 1 back. And no real number exists. So it's an imaginary number. All right? So the square root of 25 is 5. The square root of negative 1 is I. And here's my answer to number 1. 5i, because the square root of negative 1 is imaginary. And to check my work, I squared, that imaginary number squared gives you negative 1. All right? I'm going to take this fact and I'm going to put it here. I squared is negative 1. And I'm going to establish a pattern. And remember I said patterns earlier. I to the 0, anything to the 0, real or imaginary, anything to the 0 is 1. That's easy. I to the first power, anything to the first power is itself. Like 7 to the first power is still 7. I to the first power is still I. I squared is negative 1. And I to the third, I actually showed my work here. I to the third comes from, if I split it apart, I squared times I to the first. Right? Because I add my exponents. 2 plus 1 is 3. So I to the third comes from I squared times I to the first. But what's I squared? We established that it's negative 1. What's I to the first? We established that's I. So really this is negative 1 times I. And negative 1 times I is negative I. So here are my first 4 answers. And I'm establishing a pattern. Let's go from I to the third. Let's go to I to the fourth. What do you think I to the fourth is? Well, I to the fourth is really I squared times I squared. This times itself. Negative 1 times itself. Gives you positive 1. And if you notice, I to the fourth repeats the pattern. The pattern now starts all over again. If I multiply this by I, if I multiply I to the fourth by I, I'll get I to the fifth, which is I again. And then I to the sixth repeats this one. And then I to the seventh repeats this one. And the pattern continues. And if I asked you for I to the eighth, hopefully you realize that it'll be 1 because the pattern repeats again and again and again. So multiples of 4, if the exponent is a multiple of 4, you go back to 1 and then you repeat your pattern again and again and again. So there's your clue, multiple of 4. So then if they ask you for some crazy exponent like I to the 39, well, you don't have to make this list all the way to 39. You can skip, you can go by 4s. I know I to the 0, I know I to the 4th, I know I to the 8th. By 12th, I know I to the 16th, I know I to the 20th, multiples of 4, I know will be 1. So I don't feel like counting by 4s. I'm a mathematician, I'm just going to go straight to as close as I can get to 39. So in my head, I'm doing 39 divided by 4. That's 9. 9 times 4 is 36. So I didn't reach 39 yet, I'm only at 36. So I to the 36, if I kept making this list, I to the 36 would be 1. I to the 37th would be I to the 38th would be -1, and I to the 39th would be -I, and there's my answer, -I. I to the 39th is the same as -I. So what you're looking for is to divide the exponent, the 39, the exponent, divided by 4, and then figure out what the remainder is. Remember remainders from 3rd grade? 39 minus 36, the remainder is 3. So what this means is, if the remainder was 0, if it was divisible perfectly by 4, I'd be here. If the remainder was 1, I'd be here. If the remainder was 2, I'd be here. Excuse me, here. And if the remainder was 3, I'd be here. So you look for your remainder, and the remainder is the pattern or the answer that you're looking for. All right? So this one is -1. Now you can figure I to the 402. By the way, divide 402 by 4. Find the remainder, which is 2. I to the 402 would be -1. Okay, so that's fun with I. Let's move on to when I shows up. I want to simplify this guy. I don't know what the square root of 18 is, but I learned to break down my numbers. So this is really positive 18 times -1 times x to the 4th times x, because x to the 4th times x is x to the 5th. Square root of 18, I know how to break that down. 9 times 2. Radical 9 times radical 2. So the square root of 9 is 3. That's my perfect square. The square root of 2, I don't know it. So I'm going to write it under my radical here. The square root of 1 is I. So my I comes out. And the square root of x to the 4th is x squared. Let me write that neat for you. So this is a 3, this is an I, this is an x squared. These are all perfect squares. I'm going to put the x squared first, then I'm going to put the I. Imaginary numbers go last in my order. Coefficient, variable, imaginary. Now radical 2 is I don't know, and radical x is I don't know, so that stays under the radical, and there is the simplified version of that. Okay, and I know you've seen my video on simplifying radicals, so it's the same thing, just with an I. Let's go here. You want to solve for x. How do you do it? I'm going to use additive inverse and subtract 48 on both sides. Cancel out. 3x is going to drop down. 3x squared is going to drop down, equals -48. Now I'm going to divide by 3 on both sides, and x squared equals, what is that, 16? So what do I do now? Oh, wait a minute, -16. So now I'm going to take the square root of both sides like I normally do, and x is alone, and x is whatever the square root of -16 is. Oh no, I'm stuck. It doesn't exist. It's 4i. 4i. Okay, so here is when I shows up in equations. Alright, I can show up for simplifying radicals and equations. Okay, so you should know how to simplify radicals. You should know how to use it when it comes up in an equation, and you should be able to figure out patterns, all right? So when I asked you what day would it be if it was 80 days from Monday, well, that pattern repeats every 7 days. A week is 7 days. So I would divide 80 by 7, and that would be, I'd get to 77. My remainder would be 3, so that means it would be 3 days after Monday. Tuesday, Wednesday, Thursday, okay? Answer was Thursday. Here is another use of I, multiplying, but I'm going to save that for another video. When you multiply what's called complex numbers, you do the same thing, FOIL, and then you use some tricks from over here. Alright, see if you can figure it out on your own. If not, stay tuned. Thanks for watching. See ya.